All right, let's jump right into this explainer where we are going to uncover exactly how B4XDaisyOTP brings flawlessly designed native pin entry views directly into the B4X environment. Now, if you've ever had to build a smooth, modern authentication screen from scratch, you already know exactly how tricky and, let's be honest, rage-inducing it can be. So today we're unpacking a solution that is absolutely as visually stunning as it is technically robust.
Our roadmap for today is pretty straightforward. First, we'll cover the mobile OTP challenge, then introducing B4XDaisyOTP. Third, ultimate UI flexibility. Fourth, advanced states and patterns. And finally, under the hood mechanics. Let's get into it.
Section 1. The Mobile OTP Challenge. Why exactly is native PIN entry so frustrating?
Building something as seemingly simple as a 4-digit bankcode input is often just a complete nightmare on mobile devices. And why is that? Well, because mobile devices simply lack the standard web APIs needed for those smooth multi-box code inputs that users have come to expect. So developers are usually left fighting with clunky native keyboards, custom focus shifting logic that misfires halfway through, and broken backspace keys that just trap the cursor. It completely ruins the user experience right at the absolute most critical moment, authentication.
Moving on to Section 2, introducing B4XDaisyOTP, bridging the web-to-native gap.
To completely solve this friction, B4XDaisyOTP acts as a direct bridge. It literally takes the highly refined design patterns of the modern ion-input-otp web component, the one found in Ionic v8, and translates them seamlessly into native, high-quality views for both Android and iOS. Essentially, it gives your users that flawless, modern web experience directly inside your compiled native app without missing a single beat.
Section 3. Ultimate UI flexibility. Styling from code to canvas.
This component is a total game changer because it allows developers to visually dazzle their users without writing endless boilerplate code. It's incredible how easily you can switch between round, soft, or rectangular shapes, but it goes way deeper than that. You can apply specific Tailwind-style rounded tokens, like rounded medium at 6 pixels or rounded full, and instantly switch between clean outlines or substantial solid fills. And the best part? The whole shebang is done directly in the Visual Designer. Absolutely no manual drawing code is required.
Beyond just box shapes, you can rapidly scale the structural layout using dimension tokens that range from extra small all the way up to extra large. Plus, you can place incredibly precise dot separators between specific index boxes. Say you want a separator after the first and third numbers. You just feed the component a simple string like 1, 3, or all, and it flawlessly formats the visual layout for you.
Now, for the developers tuning in who want to know the exact levers they can pull, the designer gives you total control over these parameters. You can set the length anywhere from 2 up to 10 boxes. But what I really love here is the dynamic gap property. By default, it's set to -1, which means the component automatically calculates and scales the gap size proportionally based on your chosen size token. It keeps everything mathematically balanced without you having to guess the pixel counts.
Section 4. Advanced states and patterns. Dynamic input handling.
Visual styling is fantastic, right? But apps need to be interactive. Not only can you trigger distinct visual validation states, like a bold valid green or an invalid red, but the input handling itself is incredibly powerful. The pattern property actually uses standard regex character classes to strictly control what the user types. So you aren't just limited to numbers here. You can natively enforce all sorts of global inputs, ranging from simple capital Latin letters to Greek characters, Arabic script, or even Chinese Han characters.
And this dynamic handling extends deeply into the theming capabilities as well. By utilizing the variant and focus variant properties, you can ensure the input boxes flawlessly match your app's overarching color system the exact second a user taps them. Whether you need a primary blue, a success green, or an error red, these custom CSS variables are mapped perfectly to DAISY tokens to give your users immediate tactile feedback.
Okay, Section 5. Under the hood mechanics, the technical ingenuity.
Let's step away from the canvas for a minute and really dig into the clever back-end mechanics that make this component so robust. Because designing pretty boxes is one thing, but making them work perfectly on mobile, that is a whole different beast. We're going to look specifically at how the component natively solves one of the most notoriously frustrating mobile problems out there, handling the backspace key on modern soft keyboards.
The original author actually left this fantastic explain like I'm 15 note directly in the source code.
They point out a massive flaw. Android's standard edit text doesn't trigger an event when a user presses backspace on a box that is already empty. And to make matters worse, predictive soft keyboards like Gboard completely bypass standard Android key events. They talk directly to the input connection, which normally breaks the intuitive OTP deletion flow entirely.
So how in the world did they fix this? Well, the developer built a custom OTP box Java class that acts as an input connection wrapper. This wrapper essentially sits between the keyboard and the app, and it actively intercepts specific low-level deletion commands, like delete surrounding text, straight from the keyboard itself. By catching that empty delete, it fires a custom event back to the B4A code and manually bounces the user's cursor backward to the previous box. It is a highly elegant native solution to a really stubborn quirk.
Furthermore, the internal B4X logic relies on some very smart state tracking flags to keep everything stable. Take the im is populating flag, for example. This is absolutely crucial so that when your app automatically pastes in a 6-digit SMS code, which happens programmatically across multiple boxes at lightning speed, it doesn't accidentally trigger a cascading loop of focus changes and text-changed events. It instantly halts redundant logic, it respects read-only states, and it smoothly shifts the cursor using request focus.
We've really seen how this seemingly simple UI element requires some deep technical consideration to get right. So, with unmatched visual flexibility perfectly mapped to Tailwind tokens and bulletproof custom Java backspace mechanics operating silently under the hood, how will you use B4XDaisyOTP to finally fix your user's authentication experience? That is all for today's explainer. Thank you so much for diving into the code with me.